Welcome to Chem Vid, where you will learn all about chemistry in a few videos spanning over the year. So, watch the video, fill in the guided notes, and make sure you take your own notes, like on the sides. Don't just listen for the answers. Really try to understand what's going on in these videos, and it will help you a lot. Alright? So let's get started with Chem Vid on matter. Matter can often be confused with things like mass or just like anything that is there, anything that exists, but it actually has a specific definition. Anything that has mass or takes up space. So it has to have mass, it has to have some type of physical presence, and it has to take up space. So for instance, this beautiful flashlight that I have drawn has mass, it has atoms, it's there, you can weigh it, it's there, and it takes up space. So a flashlight is matter. However, the light that comes out of a flashlight does not have mass. Okay? And if it doesn't have mass, it cannot be matter. So light is technically not matter. That's the same thing that when you look at a fire. Alright? So a fire is made up of wood. You have wood that's being burned down here, and then you have light that's coming out of it. Well, the light is not matter, and the heat that the fire produces is not matter, but the wood and the fire itself is matter. So when we're thinking about matter, there are three different types of matter: solids, liquids, and gases. So when we're talking about the shape of it, of a phase of matter, solids maintain their own shape. You can't change the shape of a solid. So it's called a definite shape. Whereas a liquids take the shape of their containers. So they don't have a shape at all because they just take whatever container they have, the shape of the container. Gases are amazing because even if you put them in a balloon, the gas molecules are moving so fast that they don't even take the shape of the container. They move around so fast that they don't have a shape. So their shape is just non-existent. When we're talking about the volume ties in with the shape. So if I have a solid, no matter what I do to that solid will always have a fixed volume. It's always going to be 1 milliliter, 2 milliliters, 3 milliliters, whatever it is. A liquid, if I have 4 cups of orange juice and I pour those 4 cups of orange juice from a large pitcher into a glass, it's still going to be 4 cups even if it has a different shape. So liquids also have a consistent volume. But gases, on the other hand, gases are moving so fast that sometimes their volumes can shrink and expand depending on their situation, depending on if you're pushing them together or pulling them apart. So gases don't actually have a specific volume. And because of that, gases can actually be compressed. You can put a gas into like an air compressor, and it'll push all the gas molecules really, really close together, and it increases the pressure of those gas molecules so that when you go to fill up your tire, you can put the air in and it'll flow through. That's what we mean by air compression. But liquids and solids, you cannot compress those guys because their molecules are already close to one another. You can't get them to get any closer. So liquids and solids can't be compressed, but gases, they can. So if you think about it, go ahead and take a moment and fill in an example for each of the solids, liquids, and gases. So as a review, solids have a fixed shape, they have a fixed volume, and you cannot compress them. Alright, you can't force them to go any more together because they're already like that. And the example I used was a chair, but you can use any solid you want. A liquid doesn't have a specific shape, but it does have a distinct volume, right? 4 cups of orange juice is 4 cups of orange juice no matter where you put it. And a liquid cannot be compressed because those molecules are already really close together. You can't do it. And I use Gatorade. You could use water, orange juice, milk, whatever liquid you choose. Alright, so gas does not have a fixed shape because they're moving so fast. It doesn't have a fixed volume because they're moving so fast and it can change. And because of those characteristics, a gas can be compressed because you can force those molecules to get closer together and become compressed. An example I used was steam. So when I boil water and that lovely water vapor comes out, that's water in the gaseous form. Alright, so now that we know the 3 different types of matter, we're going to go on to some properties of matter that help us to describe. Because as scientists, when we see something, we have to be able to give it a description. We need to know what it's made out of. So here are a few characteristics that we talk about, properties that we talk about. Okay, so the big thing that we talk about in this class is physical versus chemical properties. A physical property is when you look at something and you can see it, and you are aware of it, and it's just all its own. Okay, so you can measure it without changing the identity or the composition. So for instance, if I looked at an apple has a red color. I don't have to change that. I don't have to perform tests or anything. I can see that it's red. All right. So physical properties are things that you can see. All right. Things that don't depend on anything else. Whereas a chemical property is a property that depends on how it will react to another factor. Okay. So the way a substance may change or react to form other substances. So if I take a piece of paper is white, okay, a white piece of paper, that's its physical property, I can see that. But the only way I know if a piece of paper is flammable is if I take a flame and I put it with the paper. That's a chemical property. A chemical property depends on another factor. So flammability is one. Oxidation, if it's going to react with oxygen or not, like rust. Okay, so anything that is all by itself is a physical property. Anything that relates to things, you have to do something to it to see how it reacts, that's a chemical property. So go ahead and over here, I want you to do the practice problem. Tell me if it's a physical or a chemical property. Now that you've done that, so iron and oxygen form rust. That is a chemical property because iron and oxygen have to react in order to form rust. There actually has to be something between those two in order to have a chemical reaction. Iron is more dense than aluminum. So dense means like it will sink or float, okay? So iron, well, I can see that iron sinks or floats by itself. I don't have to compare it to anything else. Aluminum, I can see if it sinks or floats by itself. So I don't have to change their property. I don't have to change its composition to see if it'll be more dense or less dense. So that's a physical property. All right? So our next one is intensive versus extensive properties. So an intensive property is, I like to think of it as internal. Okay, so intensive means internal. It doesn't matter how much of the substance you have, that property will always stay the same. For instance, water has a density of 1 gram per milliliter. Okay? It doesn't matter if I have 1 quart of water or 10 gallons of water. The density of all water is 1 gram per milliliter. It doesn't change no matter how much I have. Whereas an extensive property depends on the amount. So extensive properties are things like mass, volume, anything that when you're measuring it, it depends on how much you have. So for instance, when I look at water, if I have 1 cup of water versus 10 gallons of water, that volume is different because of my sample size. Okay? So extensive is all about the amount. Intensive is just identifying that substance kind of character. I like to think of it as like internal. Whereas extensive is external. It's how much you have. Okay? So if I look at practice problem number 2, go ahead and look at those and give it a shot, answer those, and then we'll come back. Okay, so how much does a potato weigh? Weight is determined by how much there is, so that's an extensive property. How tough a diamond is, that's like how hard it is to break it. So that is internal. That's all about how a diamond is made up of. And it doesn't matter if I have a really big diamond or a really little diamond. Diamonds are always tough. So that would be an intensive property. Okay? So qualitative and quantitative properties describe measurements. Okay? So qualitative is descriptive, whereas quantitative has a numerical value. For instance, if I look at an apple is very light. All right? It's just light. That is a qualitative property because I'm describing the apple, but it's not very specific. A quantitative measurement would be something like an apple weighs, 0.5 pounds or something like that. Because that actually has a numerical value, and so you know exactly how much the apple weighs. Qualitative is descriptive, like quality. Okay, quality is more of a descriptive thing. Quantitative is like quantity. How much of it do I have? So when we're looking at changes, we are going to manipulate things so that something happens. There are 2 different types of changes we're going to look at for. Physical change and a chemical change. A physical change does not change what that substance is. It has no effect on how the atoms are connected. Okay? So water, if you look down here, water has an oxygen with 2 little hydrogens popping off. Okay? And in a phase change, or in a physical change, the water molecules are just getting slowly pushed together, or getting more freedom. But no matter what, they're still water molecules. It's still an oxygen with 2 hydrogens. Okay? So a physical change, nothing changes except for maybe how the substance looks or how free the molecules are to move, but it's still water. It's still that substance. Whereas a chemical change is where you do rearrange those molecules so that you've created something new. Okay? So if I look at this methane, methane has a carbon and 4 hydrogens, and then oxygen is always bonded to itself. But if I look after the change, now the carbon is attached to the oxygens, and the oxygens are attached to the hydrogens. I have broken bonds, and now I've created something new. So this is how a chemical change works. If you create something new, you have done a chemical change. Alright? So if I look over here, practice problem number 4. If I boil water, does the water actually change from a liquid to a gas? Like, I added heat. Is it still water after I boil it? Well, yeah. It went from liquid water to gaseous water. It's still the same substance, just in another form. Whereas fruit rotting, I have this nice, yummy peach, and as it starts to rot, it starts to release that lovely odor, right? That odor is of the gas that is new to you. So smell is a great way to see if something new is happening because you can smell the new chemicals being made. So when we're talking about changes, we have to always remember law of conservation of mass. The mass of your reactants, or what you start with, has to equal the mass of your products. Alright? So if I start off with 2 grams of reactants, then I'm going to have 2 grams of products at the end. Okay? So what I want you to do before class, problem 5 and problem 6, go ahead and give those a whirl. And then we'll discuss those in class, and we'll finish up the notes on how to classify matter, and then we'll do our activity in the next class. Alright? Good job, guys!